Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be labeling transverse and longitudinal waves. Okay, so we start off with the following. We have a transverse wave here. Notice it's that S shape which we looked at last lesson. The top part of the wave is called the peak of the wave. So this is also the peak. So the peak of the wave is the top part of the wave. The bottom parts are going to be called the trough of the wave. Trough is also a trough. The distance now from the equilibrium position to the top, to the peak, so this distance here, this is called the amplitude. And it's the same as this distance over here. This is also the same thing. The higher the amplitude, the greater the loudness of the sound. So amplitude, it tells me it's like the loudness. So if obviously, like, imagine you're listening to music on your, I don't know, your iPhone, and if you increase the amplitude, you're basically making it louder. Right, so the next thing to label is the wavelength. The wavelength is from one point of the wave to its next matching point in the cycle. So in this case, it's going to be from peak to peak. It's the same point in the wave, just the matching one next to it. So that distance here is called the wavelength. And that's the same distance as trough to trough. That's also the same distance. Why? Because now it's the trough to the next trough. That is also the wavelength. So this is also the wavelength. Right, in physics, rather than writing down the wavelength multiple times, we can put down a symbol. So the symbol is going to be this, the Greek symbol lambda. So that stands for the wavelength. And the units for the wavelength, it's measured in meters. So it's a physical distance. It's an actual physical distance. So if I take out a ruler, it's that distance between the peak to the peak. Okay, so now we're able to label the parts of a transverse wave. Now, what about a longitudinal wave now? What about a longitudinal wave? It looks slightly different. So notice we have the slinky spring, and if I'm shoving it one direction, we notice that parts of it bunch up and parts of it spread out. The parts where they bunch up, so right now, bang in the center, where they bunch up, this is called a compression. And the parts where they're furthest away, let's label that in a different color over here. This is called a rarefaction. So we're just labeling it. So here's another one. Here's another rarefaction here. Right. Do longitudinal waves have a wavelength? Yes, they also have a wavelength. It is labeled from compression to compression. So this distance here, compression to compression, this is the wavelength. Yeah? So if someone gives you a longitudinal wave and they say to you, well, where can I look at the wavelength? You just look at one compression, find the next compression. That distance is called the wavelength. And once again, the wavelength, the symbol is going to be lambda. And the units are still the same. It's going to be measured in meters. Happy with that? Yeah? Easy stuff. Right, so scrolling down, test your understanding. Which wave has the longest wavelength and which has the highest amplitude? So I've got two waves here. Which of them has the longest wavelength and which one has the highest amplitude? So wavelength, let's label it on this one. There to there, that's the wavelength. Good, that's this wavelength. Label it lambda. And the other one, there to there, this one is also lambda. Yeah. Which one is bigger? Well, we clearly know this one has a higher wavelength here. This one is a high wavelength. This one is a low wavelength or shorter wavelength. Now, next thing is this. Which one has the highest amplitude? Let's label it. So the amplitude of this one is over here, right? The amplitude of this one is quite higher. So which one has the highest amplitude? It's going to be this one. So it's going to have a high amplitude here. And this one's going to be low amplitude. So this one has the high amplitude. Just delete that. We would have got it twice. Right, so we can clearly see that the first one has a higher wavelength, longer wavelength. Put the word longer, longer is better. So let's go for longer wavelength and a lower amplitude. The other one has a shorter wavelength, but a higher amplitude. Easy stuff. Now, scrolling down for the summary. So the wavelength of a wave is the distance between two matching points on neighboring waves. So it's a distance between two matching points on neighboring waves. The wavelength of a wave is measured in meters. Longitudinal waves have compressions and rarefactions. Both longitudinal waves and transverse wave have wavelengths which we can measure. And for the transverse wave, make sure we can label the different parts. We know that the top part is going to be called the peak, bottom part is going to be called the trough, and the distance from peak to peak there is the wavelength. Oh, and we're missing the amplitude. From the middle to the top, this one is the amplitude. And that's it for today's session. I shall see you next time for some more cool physics.